Hello everyone, my name is IOcken. I am enrolled in ECE 312, 332, and 342. Today I'll be talking to you about the signal transmission in a radio system. So our topics today, we're going to go over frequency modulation, frequency multiplexing, different environments for which a signal can propagate through, and mixing within this circuit. So we're going to start with frequency modulation. And a normal voice signal is between 300 hertz and 6 kilohertz. And without modulating the signal, your antenna, according to the lambda equals C over F, with your frequency and the speed of light, you'd need a 100-kilometer long antenna, which is stupidly impossible. But if you modulate the signal to high frequencies, that's when, like around 900 megahertz, that's when your antennas will become much more reasonable, like in the ranges of centimeters in this case. And modulation means you have your voice signal multiplied by your carrier signal, and that gives you modulation. And here we have band pass filter setup. So it's the combination of a low pass and high pass, and this is so you can, on a radio, you can tune out different frequencies around your given, what you want to listen to your audio. And these the carrier signal must be a periodic wave, whether it's a cosine wave, some other sort of disguised cosine, and thus from this it'll have a fundamental frequency and a Fourier series representation. So we move on to frequency multiplexing, which is most bandpass filters have a bandwidth of 6 kilohertz, and after you go through the modulation, you have to demodulate it to get it back into the audible human range. And this can be done, different signals can be sent via fiber optics and such. So the signal, your X of t, will be multiplied by a carrier signal, which will get you your bandpass filtered one over here, and it'll be at the carrier signal, which is around 900 megahertz, so very large, and you'll have that bandwidth. And the point of multiplexing is you have your X of t, which is 5 kilohertz bandwidth per se, and your carrier one will have close to 50 gigahertz, so you can fit 50,000 X of t's in there. So it's just, you can have a lot of different things like that. All right, environments. This is mostly deals with antennas and selective signals, and in this case, you have your WA signal, which is right up here, and it'll have no loss in transmission on the signal because it's at 0 decibels. And take an ocean, for instance, it'll be more of a low pass filter like this, so it's good to transfer low frequencies. And you have your differences of AM and FM radio, I'm sure you know about that, your amplitude modulation and your frequency modulation. And say an AM radio, if a tower is struck by lightning, the amplitude will change drastically, but the FM will not change because it deals with frequency. And moving on to mixing, you have your preamp part of the circuit, and this gets it ready. It does three things. It amplifies and it conditions for the next stage, and it also filters, and that next stage will be mixing in the preamp. And in the mixer we have our local oscillator, which contains the LC circuit tank, and this will be emitting electrical and magnetic energy across the capacitor and the inductor. And this pace of the oscillation is known as the resonant frequency, getting it to modulate like this. And they do not dissipate energy. The only, in an ideal one, in a normal one, you will have some attenuation over time. And you can tune to a given signal by tuning the capacitor, because this is a tunable capacitor. And this is all done on top of a transistor. And the mixing process is you take your VN input and you multiply it by the mixed or modulated transconductance over here, your gain, multiply those two together, that's mixing, and the load will give you the filtering aspect, and this is all done from the transistor. It's pretty cool. It does mixing and amplification, as well as filtering. It does all these things in this given circuit to take the radio frequency from the input and modulate it, then mix it, and go through a bandpass filter to tune it, and then eventually go out of the antenna to transmit it. Thank you. Have a good day.